In this video, we will try to find the equation, in standard form, of the ellipse, with the following given. For basic concepts on ellipse, you can check the previous video lecture. You can also pause this video, to try these yourself, and continue playing to check your answer. Now, without further ado, let's start. For the first problem, we are given the length of minor axis that is 12, the center at 2, -1, and the foci, 6 units above and below it. First, we need to know the orientation of the ellipse, so that we will know what equation to use. This equation is for horizontal ellipse, while this equation is for vertical ellipse. Notice how a squared and b squared switched when the orientation of ellipse has changed. Now how do we know its orientation? Using the property of foci on an ellipse. Note that the foci always lie on the major axis. And so, if the foci is above and below the center, then the major axis is vertical. If the major axis is vertical, then the orientation of the ellipse is also vertical. Hence, we use this form. Since we already learned that h and k are the coordinates of the center, and the center is given at 2, -1, we can just substitute these values to our equation so that we will have this. The next step would be identifying the values of a and b. We learned from the previous lecture that b refers to the distance from center to any of the co-vertices, and covertices are the endpoints of the minor axis. From center to any endpoints of the covertices, the distance would be half of the minor axis, because the center is the midpoint between the covertices. And so, for this given, the minor axis has length 12, then the distance of b, our half of the minor axis, would be 6. We can now substitute that to our equation, so that we have 6 squared or 36. Another given in this problem is the distance of foci from the center, which is 6. This is denoted by the variable c, hence, c equals 6. This will be needed to find the value of b, using Pythagorean theorem. Substituting the values for b and c, we have a squared equals 6 squared plus 6 squared. Simplifying this, a squared equals 36 plus 36, or 72. We can now just substitute this to a squared in the equation as is. So our equation, in standard form, is x minus 2 squared over 36 plus y plus 1 squared over 72 equals 1. For the second problem, our given are foci at 0, -3, and 0, 7, and a vertex that is 4 units below a focus. For the orientation, since 0, -3 and 0, 7 will pass through the y-axis, that is vertical, and again, foci lie on major axis, thus, this ellipse is vertical and will have this equation. From the given foci, 0, -3 and 0, 7, we will find our center. Take note that the midpoint of any pairs of points, like vertices, covertices, and foci, is the center of the ellipse. So we need to find the midpoint between the foci, to find the center. Midpoint is the average of coordinates of 2 points, so, if we have 0, -3, and 0, 7, the midpoint will be 0, 2. This now is the center of our ellipse. We can now substitute it to h and k in our equation, so that we have x minus 0 squared are simply x, and y minus 2 squared. After finding the center, we now have to find the values for a and b. Because we were given the foci, we can have the value for c, are the distance from one focus to the center. we can use distance formula, or just simply count it in the Cartesian plane. Hence, c equals 5 units. It is also given that the vertex is 5 units below the focus 0, -3. Take note that it can't be below the focus 0, 7 because vertices are farther away from the center than foci. Going back, so if the focus is already 5 units away from the center, we will add another 4 units to get the distance of the vertex to the center. Hence, we have a equals 9. We can now substitute it to our equation so that a squared becomes 9 squared, or 81. To solve for b, we will use Pythagorean theorem. We can rearrange the formula so that we will have b squared equals a squared minus c squared. Substitute the given values, we have b squared equals 9 squared minus 5 squared. Solve it, we have b squared equals 81 minus 25, or b squared equals 56. We can now just substitute this to our equation, since in our standard form of equation, what we need is b squared. Hence, our standard form is x squared over b squared, or 56, plus y minus 2 squared over 81 equals 1. For the last problem, our given is an ellipse with vertices -3, 4 and 17, 4, and passing through 15, 7. Since the vertices, when plotted on a Cartesian plane, will form a horizontal major axis, the orientation of our ellipse is horizontal as well. Therefore, we will use this equation. As for the center, it is the midpoint of the vertices. So solving for the midpoint, we have 7, 4. This is now our center, and we will substitute it to h and k on our equation, so we have x minus 7 and y minus 4. After that, we can now find a and b. A is the distance from one vertex to the center. We can use distance formula, or, if we plot our vertices on the Cartesian plane, we can just count how many units one vertex is to the center. In this case, it is 10 units. Therefore, a is equal to 10. We can now substitute it to our equation, then square it, so that a squared becomes 100. Now, to solve for b, we can't use Pythagorean theorem, since we don't have focus or minor axis as given. But we have a point on the ellipse at 15, 7. Note that the point on ellipse is denoted by xy, hence, we can substitute it to the equation in order to find b. Simplifying this, we have 15 minus 7, or 8 squared, over 100, plus 7 minus 4, or 3, squared, over b squared, equals 1. 8 squared is 64, and 3 squared is 9. Transpose 64 over 100 to the right side of the equation, then solve for 1 minus 64 over 100. We can have it as 100 over 100 minus 64 over 100 is 36 over 100. Simplifying 9 over b squared equals 36 over 100, we can cross-multiply them so that we have 36b squared equals 9 times 100 or 900, dividing both sides by 36. To solve for b squared, we have b squared equals 25. Therefore, our b is equal to 5. Substituting it to our standard form of equation earlier, we have x minus 7 squared over 100 plus y minus 4 squared over 25 equals 1. This is now our equation of the ellipse in standard form. Thank you again for watching. Hope you learned something from this video. If you do, kindly give us a like, subscribe, and hit the notification bell to get more lessons in mathematics for senior high.